Children, let us study some standard continuous functions. Okay, this is your NCERT textbook. So for quick revision, I have done this. Okay, so constant function is continuous. You know the graph of constant function, children. How is the graph of constant function? It is suppose y equal y equal to 3. So constant function. So how it is? As I told you pictorially without lifting pencil, if you are able to draw the curve, it is a continuous function. So you can see here it is continuous. If you want, you can prove it also. For example, they have taken let f of x equal to k, where domain is real number. Then by definition, what will happen? Limit as x tends to c, f of x equal to f of c. Because what happens? Your f of c is some constant. Right, so anywhere of x, whatever value of x you take, it will be always a constant. So you can say constant function is continuous. Now the next one is identity function. What do you mean by identity function? Identity function means anything is mapped to itself. For example, y equal to x. How is the graph of y equal to x? Like this. Again, it is very clear from the picture without lifting pencil. So it is a continuous curve. Right. So you can see, let c be any real number. Limit as x tends to c, f of x is nothing but x. Right. Because the image of f of x is x. But when x tends to c, when you apply the limit, x will become c. Also f of c is c. You put c here, c. So you can say identity function is also continuous. The next one is polynomial function. Right. Polynomial function is also continuous function. You can see here. Let f of x equal to, this is how a polynomial is written, a0 plus a1x plus a2x square plus dot. Now each function you can see that is continuous, right? So sum of all of them will be continuous. Or if you want, you can try this also. Be a polynomial, the domain, let c be any real number, limit as x tends to c, f of x will be equal to f of c. So instead of x you put here c, this will all be a polynomial in c raised to n. So that is nothing but f of c. Okay, therefore f is continuous at c. The next function is children modulus function. Okay, let's check what happens to modulus function. Now f of x equal to mod x, you know that we have discussed it in the lesson number 2. F of x is minus x. If x is less than 0, it is 0. If x is 0, is x. If x is greater than 0. Okay, now when x is less than 0, children, what happens? Your f of x equal to minus x. So this is a polynomial function. So it is continuous for minus infinity to 0. Right. Now when x is greater than 0, children, what happens? Your f of x will be taking value x. Again, it's a polynomial function and polynomial function is continuous. Now when x is 0, what happens, children? When x is 0, what happens? Limit as x tends to 0 minus f of x will be same as 0. This is 0. So left limit, right limit will be 0. So you can see that modulus function is continuous everywhere. Right? You know how is the graph of modulus function? It is V-shaped. No? Like this it will go. Without lifting a pencil, it will go like this. Okay. And the next function. So don't forget these functions. Okay. So you can say here modulus is continuous on R. Now the next function is rational function. You know that children, rational functions are made of polynomial functions, and division of two rational function will also two polynomial function will be again polynomial function. So polynomial functions are continuous, and you know that if f is continuous, g is continuous, f by g is also continuous. So that's why I can write here polynomial function is also continuous. Now sine function, you have seen the function, you have seen the graph of sine function, children. Yes, sine function is also continuous. Yes, you have seen this. No, it is oscillating like this, right? Continuous function, cos, tan, everything, right? But tan and all, we have limit. You have certain points of break. No, at that position it will be discontinuous. Okay, so we have to take care of that. So if I take sine x is continuous, if you want, you can prove this also. Limit as x tends to c plus limit as x tends to c sine x. You are making a substitution here. Put x equal to c plus h. Okay, so you can see it is sines. So apply the formula of sin a cos b plus cos a sin b. Okay, h is 0. So this will become 1. So it is sin c. Cos c. This will be get cancelling. So it will cos c into 0. It will get cancelling. So it will be sin c. That is same as f of c. Okay. See why I made a substitution in x equal to c plus h? Because c plus h, if I choose sufficiently very small, say 0.0001 like that, then what will happen? Your f of x will become f of c. Similarly, same way you can prove cos is also continuous function. Yeah. Same way, put the substitution cos of c plus h, cos a cos b minus sin a sin b, apply the limit. This will become 1. So it is cos C. This will become sin 0 is 0 minus 0. So it will be again cos C. So you can say that cos function is also this. Now what about tan function, children? Tan function, you know that there are points where there are breaks. So if I remove these points, children, your function will be continuous. Okay, so that's why I've taken the domain as r minus 2n plus 1 pi by 2. So tan is sin by cos. Sin is a polynomial function. Sin is a continuous function. Cos is also a continuous function. So continuity of continuous function upon continuous function is again a continuous function. So tangent function is continuous. In fact, all trigonometric functions are continuous if you remove the points of break. Then the next important one is continuity of the greatest integer function. Okay, so there will be different cases for greatest integer function. In the last year we have studied, no? Yes, if I have a point, if I have 3.1, okay, what is the greatest integer value less than or equal to x? It is 3. Yes, but if it is minus 3.1, what is the greatest integer value less than or equal to x? It is minus 4, right? Because we are looking for the greatest integer smaller than or equal to x. Okay, so there can be two situations. X can be an integer or x cannot be an integer. So if x is an integer, what will happen? Suppose if it, now that integer can be approached from left side or from right side. So limit as x tends to c minus f of x will be limit as h tends to 0. Now you remember I have put x as c plus h. So this time it is from left side. So I'll put it as c minus h. So f of c minus h means this is f of x, no? So integer part of x will be c minus h. Okay, so this is from left side. So it will be shifting one number to your left side. So it is c minus 1. Okay. So next one, limit as x tends to c plus f of x is limit as h tends to 0 f of c plus h. So that means integer part of c plus h. Just now I told you if it is 3 plus 0.1, it is 3.1 and integer part of 3.1 is 3. Similarly, if it is minus 3 minus 0.1, what it is, children? Yeah, it is minus 3.1. So it will be minus 4. Yes or no? So you can see that left limit, right limit is not same. Therefore, I can say that when c is an integer, your function is not continuous. Okay. Now, what about if c is not an integer? If c is not an integer, children, you know that it will be in some decimals and decimals. Because it is in decimal, you can put it in between any two integers, right? That's why I've written here. If c is 2.3, it can be put between 2 and 3. Yes. So what will happen? For sufficiently lesser values of this, it will always take the value n. So limit as x tends to c minus f of x will be limit as h tends to 0 c minus h, because c is already an integer. Yeah, so if I take c as 2, it is 2 minus 0.1. 2 minus 0.1 is what, children? If it is, I said c is not an integer, it is 2.1. So 2.1 will be between 2 and 3, no, children? So c is not an integer, so it is 2.1 minus 2.1 and h is 0.1. So 2 minus 0.1, how much it is? 1.9. 2 minus 0.1 is 1.9, right? So 1.9 will be having the greatest integer less than or equal to x as 2. That is nothing but my n. Yes or no? This is n, this is n plus 1. Okay, same if I take 2 plus 0.1, it will be 2.1, right? 2.1 is also greatest integer less than or equal to x will be 2. So that's why both the values are n. You specifically put examples, children, you will understand it. Okay, so f of x is continuous at c. So therefore integer, the greatest integer function is always continuous at non-integer values, whereas at integer it is discontinuous. Okay. Also, children, one important result I would like to discuss. See, these are all theory part. I am just rushing off with this because these are not, these are just the minor things about continuous functions. The more thing is solving our problems. Okay, so next class onwards we'll solve problems, then you will understand better. So you can see that sin x and cos x are continuous function, then sin x plus cos x, sin x minus cos x, sin x, cos x are also continuous functions. So that's all for today. I know I have done today class in a bit speed because I want to emphasize more time on problem solving. Okay, continuity, definition, everything it is okay, but problem solving is more important. Okay, thank you children. I hope you have understood.